Do your lights flicker or dim when your AC or heat pump starts up? Maybe it makes a loud bang on startup. Or maybe you've tried to power your RV or home's heat pump system with a generator or solar power system, but when the unit tried to power up, it overloaded your system. That's because of the massive current draw called inrush or startup current that happens when these large induction motors power up. There's multiple solutions on the market to solve this problem, but they don't all work. Today, I'll show you options that do work incredibly well, options that don't work, and one option that actually blew up. I'll show you how to wire one of these and prove that it actually works. Welcome back to Projects with Everyday Dave. Let's get started. You'll find a couple of different options in the market. This one is a hard start capacitor. They're very inexpensive, somewhere around $30. It's just a large capacitor and a relay to connect and disconnect it for startup. If your compressor is having a hard time starting, this unit can give it a boost, but it does not reduce the inrush current load. I tested this one and it made zero difference in the current draw at startup. This is a SoftStart system. They are much more expensive in the $300 to $400 range, but they work in a completely different way. When your air conditioner or heat pump first kicks on, the compressor tries to go from a dead stop to full speed instantly, and that surge of electricity can be 4 to 5 times higher than the normal running current. The best solution to reduce that instantaneous surge is a soft start system like this one. A soft start is like a dimmer switch that gradually brings the voltage up over about a second or two. Instead of slamming that motor to full power all at once, it eases it up to that speed. This reduces the startup surge dramatically, which means less stress on your compressor, no lights flickering in your house, and the ability to run your AC on a smaller generator or inverter than you normally could. Today we'll be installing the SoftStart Home, which is spec'd for up to a 6-ton AC or heat pump. Mine's 4-ton. There's a reason I chose this particular unit. I was using another brand previously and it was working great for about 2 years. And then the capacitor inside literally blew up. It sounded like a gunshot going off in the basement. The parts were contained within the box, but it did split it open. I'm not going to disparage the company that made it because it was a prototype they sent me for testing and I'm sure they've improved it since then. But I'm done testing and now I just need something that will work reliably for a long time. Signature Solar, who I've worked with a lot, sells this SoftStart Home. And I called them to see if they've had any warranty issues with this and they said that they haven't had any. So I bought this one, we'll be installing it and testing it, and in the future I'll be trying some other brands as well. I'm installing this unit on my 4-ton geothermal heat pump. This unit I purchased is rated for up to 6 ton, which should give some margin. I'll leave links to this one and another one that gets good ratings but has Bluetooth monitoring in the description below. If you do purchase from Signature Solar, you can get a $50 discount on a purchase of 500 or more using my link and exclusive code in the description below. You can also find additional discounts and everything you need to know for going solar on my website, projectswithdave.com. The wiring's actually pretty simple and it's basically the same for all heat pump and AC systems, and you can find all the wiring diagrams on their website. I'll leave a link in the description below. To start with, I'm going to measure the inrush current with no soft start. I'm using a professional fluke meter so that you can have confidence in the measurement results. And I'll show both the inrush current, which is the average over a short period of time, and the instantaneous peak current at startup. So let's start the test. I've set my meter to inrush. Now I'm testing startup on mains only, no soft start. All right, it's getting ready. Circulation pump kicked on. Start it up. See, you hear that kind of hard start sound? Now you can see the inrush current was 133 amps and the peak was 225 amps. That is really high. Now if I just measure the current draw while it's running, we're at 9.8 amps, 60 hertz, just under 10 amps to run continuously. I did a separate run measuring the minimum and maximum voltage during startup for each test case, and I'll show the result in the chart so we can see the difference in voltage sag for each scenario. Minimum was 238. Wow. There's no sag. All right, let's see if my FlexBoss 21 can start this compressor without a soft start. Okay, here it goes. Okay, it did it. Didn't sound super excited about it. Looks like 98 amps at startup and 144 peak amps. So it would have really struggled there. The voltage probably dropped quite a bit. And running, we're at 10 amps, 60 hertz, running smoothly. Inverter with no soft start. Voltage ramp. All right, let's see what the min-max was. 189. That's not terrible. It's actually better than I thought it would be. Max was 242, and it's running at 240. Before wiring, make sure the breaker's off. There should also be a disconnect right near your unit. Open the lid, pull the handle. Then you can use a meter to confirm that there is no voltage on the input. All right, now we can start. Wiring diagrams for these are almost all entirely the same. There will be a line 1 and line 2 going to the compressor, and then usually a blue or other colored wire going to the capacitor, and from the capacitor to line 2 in my case. To remove any chance of electric shock, you can short out the capacitor by crossing these two posts with a screwdriver, just to make sure that you don't accidentally get shocked, and then you can use some high voltage rubber lined gloves for just a little extra protection. For this one, we'll wire in the SoftStart Home. It has 5 wires. The red and black will go to line 1 and line 2. The brown and blue will go to the 2 legs of the compressor, and then the yellow will go to the capacitor. In some cases, your wires may already have a spade on them, like this one that I've added the spade to. They may be on a ring terminal like this one. In this case, the kit comes with all the connectors you'll need to install the system, including a little bit of shrink tube to cover up the joints and some zip ties to hold it in place. And you'll need a set of crimpers in order to utilize them. These are pretty inexpensive. If you want to do any of this kind of crimping, you'll need them. We'll use the yellow setting. I'll link to these in the description below if you need to get a set. So I can just cut off the connector that came on the unit, grip some insulation, we'll slide on the new spade connector, and crimp that down. There we go. We'll start with the main power connections. The black wire is going to go to the same line as the capacitor is connected to. In this case, for me, the capacitor is connected to line 2, so I'm going to connect black to line 2. Then the red power wire will go to the other side, line 1. Make sure they're good and tight. Now I have the blue and brown wires. I don't want these joints exposed, so before I put them together, I'll just grab that piece of shrink tube that was in the container and slide it on the wire. I'll connect the blue to the red and slide another piece of shrink tube on the black wire, and then the brown connects to the black. Now I'll be able to just heat shrink that on there, and then I'll tape the joint up. Okay, and then our final wire is the yellow. This is the line side of the capacitor. This is the compressor side, so we just connect that guy there. And that's all there is to it. Now in my case, this isn't outdoors. If it was outdoors, I'd want to make sure and mount this vertically so that water wouldn't go up in this hole. And the other version I'll show you of these soft starters has a little better seal than this one. In my case though, I have plenty of space in here and water's not a concern, so I'm just going to mount this right there. And then I can zip tie up all the wire. There's a wiring diagram for all kinds of brands on the website. If you have something that looks different, you can check it out, but they're all pretty similar. All right, now we can turn the breaker back on and reinsert the fuse. All right, we can kick it on. All right, soft start with an inverter, battery supply only. Let's see what happens. Wow, that was smooth. Look at that, 23 amps. That is amazing. Just in case you forgot, here's what it sounds like without the soft start. What a huge difference. Okay, we have min-max voltage. Minimum 236. Max is 241. Now it's running at 239. All right, time to check soft start on mains power. All right, there we go. 28 amps, the peak of 59, and current draw is 9.4 amps, just about the same as before. Soft start voltage check on mains power. Got a max of 248.2, minimum of 245.5, running voltage of 246.7. I've compiled all the results in a single chart. The inrush current was dramatically reduced, 75 amps for the grid-connected mains power and 105 amps for the FlexBoss 21 running off-grid. The peak amps was similarly improved, although not as dramatic. The voltage sag was also reduced. The voltage sag was almost completely eliminated in the inverter startup. It's really amazing what these devices can do. Even though my FlexBoss 21 could start my compressor without a soft start, the unit will significantly reduce the stress on my inverter. And you can see how it would enable a much smaller inverter or generator to operate a very large AC or heat pump compressor. So who should install one of these? First, if you have a mini split or variable speed scroll compressor, you don't need one of these. They already have a smooth startup. If you have a standard AC or heat pump and plan to run it on a generator or inverter, you will definitely want to install one of these. If your lights flicker on startup or your compressor makes really loud noises when it starts up and that bothers you, you could also benefit from installing one. For everyone else, there's a claim that these soft starts will increase the life of your AC compressor. And it makes sense that it would, but I couldn't find any data to verify that claim. They typically last 20 years, so it's hard to compare one with and without. What I do know is very high current is damaging, so in all likelihood, it's going to improve the life of your compressor. I purchased another highly rated SoftStart system, and when I'm done testing it, I'll post the results right here. If you want to see more content on solar power and going off-grid, watch this video right here. For all your solar needs, check out my website, projectswithdave.com. Thanks for watching, and I'll see you next time.